Hello friends and welcome to my channel. In this video I will repair this Sony amplifier. Let's begin. This is the amplifier that I will repair today. I like Sony amplifiers, they are good quality. Let's look what we have inside. As you can see, it's a lot of dust. First of all, you will notice this resistor. It's burned. I hope that you can see in the middle. And the fuse, it's also burned. What I like about this model is that we have access on downsize to replace the bad parts. Now, first of all, I will wash and clean the dirt. I've washed this amplifier and I let it to dry. It has to dry very well. Now it's almost clean and I want to tell you some things. First of all, you can see the power cable is cut. This is a good sign that this device is faulty. Now, I want to show you the green resistor in center. Now you can see it's fault. Also, this power resistor R525, it's also fault. And from my experience, I can bet that those two power transistors are both in short circuit, and at least one of these power resistors is fault also. It's very possible that transistor before power transistor Q510 and this one Q509 are also fault. Now let's make some measurements. I will use this ohm meter on a beeper. Now let's check this power resistor. It's fault. This one is good. Now let's check the power transistors. Collector emitter junction, it's short circuit. And this one, it's also in short. We can test on other channel. It's good. It's good. I bet that this right channel is perfectly good and only this left channel is fault. Now let's measure this power resistor. This is good. This was burned, it's not good. It's not completely open, but it's not good. This must be replaced. Now let's test this transistor before power transistors. We can always have other channel to compare. This is bad. This seems good. I also will check this small transistor before this one. Let's test it. Let's test again on this side. Short. This good. Good. This is not good. Let's compare with this one. I forgot. This should be on diode. Now let's measure again. So this is not good. This is short. Now let's test it's good. They are good. So far, these power transistors are bad, and this has to be replaced. Those two power resistors, one is fault, one is not, but I will replace both of them. And these two transistors, one is bad and one is good, and I will replace only this one. Now let's take the parts out. I forgot to check this super diode transistor. Let's test it now. This is good. Usually this one it's not fault. Now let's test again these parts. This one you can see it's burn. This one it's obviously burn. This one it's not burn, but you can see this one it's not burn, but you can see that instead of this red now it's black, and this should be replaced. Short, this one is good. The problem was on the PCB. Let's use this tester. It's perfect. This transistor is perfect. Now let's measure again on the PCB and let's see what's the cause of the problem. This small transistor is good. First of all, I should have take this out. That was surely bad. And just after that I have to measure this. Now I will put the small one back and I will test another resistors. Now let's test the small resistors around the power transistors. It's good. Let's check with this one. It's good. It's good. Good. As you can see they are symmetrical. Good. 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 There is a small transistor in the back of this one. Let's check to see if it's okay. It's good. Now I will find these parts to replace. I've prepared all the parts here, and now I will solder. Now that we have replaced the bad parts, we should not hurry to power this amplifier. First of all, this bias current adjustable should be set to minimum current, 0 current. And usually when I repair an amplifier, I don't just power up, I will put this to a differential power supply with current limiting at 0.5 amps to check that everything is good and will not fault another parts if there is another bad parts on this device. Now I forgot to test the bridge rectifier. When these power transistors are in short circuit and there is no fuse on the PCB, it's possible that this bridge rectifier to burn. Let's test it. This is the secondary coil. This bridge rectifier seems good. This is a good quality amplifier, but I don't like that it doesn't have fuses between power supply and these power transistors. As you can see, this is the differential input alternative current. It's right here on this transformer, and the only fuse it's on the primary part of this transformer. And that's what I don't like. If they put here some fuses on the second, I will put here some fuses on the secondary part. I put a differential power supply here, and now let's measure the voltage. "24 volts, 25 volts, that's good. The current limiter is put to 0.5 amps, and now power supply shows current consumption of 0.06 amps. That's good. Now I will check the voltage on the output of the amplifier. On a good channel, that's good, and now on a repaired channel, that's good. Now I will check the voltage on the power resistor. That's 4 millivolts, it's good, and on original channel it's 3 millivolts. That's good. Now I can put back the original power supply. I put here 2 fuses. I hope that you can see. 5 amps on secondary output of the transformer. I replaced the fuse and I repaired the cable. Now let's power this up for the first time. now it's on standby. Now let's power. The protection relay was triggered, then that tells us that everything is okay. Now let's measure the output voltage. On the original output, 16 millivolts, that's good, and repaired output is good. Now we have to adjust the bias current. We can measure any power resistor or this. It's good. It's 4 millivolts, and here is 6 millivolts. 7. We have to decrease. You have to be very careful when you decrease, because if you increase, you can destroy the output, the power transistors. Four millivolts, and here also 4 millivolts. That's good. Now let's make some tests. And now let's make some music test. I connected this speaker on this phone. There is a very good sound quality. I hope that you can hear it. Now let's make some tests on the oscilloscope. Now I've connected this amplifier to the oscilloscope, and we have a sine wave, approximately 1 kilohertz. Now peak-to-peak voltage is 10 volts. Let's increase to see what happens. Now we are on left channel. Now we are 15 volts peak to peak. Let's increase. We are using this dummy load, I forgot to tell you. $18 volts, 20 volts peak to peak, $28 volts, 35 volts, 38 volts. This was the channel that was repaired. Now let's test the other channel. The heatsink, it's not very warm. Now we have 25 volts peak to peak, 32 volts, 42 volts peak to peak. I must say that it's working very good. Now you can see the schematic. We'll talk only about the output when I made the changes. You can see the adjustable resistors. It's RV501. Will adjust current bias, you will see. You can see R522 330 ohms was a small resistor that I replaced. You can see also the R525 and 526, it's the power resistor that I replaced. And the Q511 and Q512, it's the power transistor that I replaced. You can see here the power transistor, it's the current amplifier, and the transistor before that is the voltage amplifier. We need a current bias adjustment so we can have good quality at low level sounds. If you have any questions, please put it in a comment. And if you find it helpful, please like and subscribe. See you in my next video.